This topic is going to show geometric probability. Sorry about the picture's a little crooked, but that's right. We have a square, which is got inside of it a circle. And let's say that we know that the radius of this circle is 5 centimeters. And they want to know what is the probability that if you threw a dart at this, that it would fall within the shaded region. All right, that's what they're saying. And we'll say that the shaded region is the entire circle. So to find the, that probability, so the probability that it falls in the shaded region. For probability of anything, it's always success, which is usually what they're looking for. In this case, that would be the shaded region, over total possible, like all possible outcomes. So if we're going to assume that you're throwing a dart and this is a dartboard and it has to land in that square somewhere, the total possible here would be the square. So for success, we want to find the area of the shaded region, because that's what we're calling success, over the area of the total region. So we do have two figures that you could consider to be the total. We do have the circle and the square, but the circle is inside the square. So if we just count that square and find the area of that, it will encompass the circle as well. We don't need to double count that. That would throw off our figures. So the area that's shaded, this is literally how I do these problems. I start here and I write out the words and I think about what is the shaded area. So now I'm going to go to words again. The shaded figure is a circle. So I need to find the area of the circle. The area of the total is what I was just saying. It is our square. So I'm going to need to find the area, and I'm just going to draw a square because this is for me, and that's what helps me. Now I'm going to go to formulas now that I have the words in there. What is the area of a circle? It's going to be pi times r squared. What is the area formula for a square? It's whatever that side measures, and you square it. So now we're ready to put in our numbers. So pi is 3.14. The radius that they tell us up above is 5. And then on the bottom, well, if I have that this radius is 5, if I double the radius, I'm going to get the diameter, which is also the entire length across that square. So 5 plus 5 means that I have a side length of 10. Now I'm ready to grab my calculator, and I'm going to type these in. So on the top, I am going to do, let's see, pi, and then times 3.1 r times 5 squared. That's going to give me 78.5. And on the bottom, 10 times 10 just gives me 100. And so when I divide these out, like if they want a probability, it's just going to be about 0.785 is the probability. And that kind of makes sense. Not that these are always drawn to scale, but my circle takes up a big chunk of that square. So it makes sense that it's close to 100%, or this, like you could count this as 78.5%. It's almost 100% full with the circle, but not quite. All right, let's look at another one. Let me move this out of the way. We're going to go through the same sort of steps, and I tend to do them the same each time. I put in words, I analyze what my success is, what shape it is, then I figure out what the shape is of the total area. Then I plug my formulas in, and finally I plug my numbers in. So just doing it little step by little step is kind of a good thing to do. All right, let's get another picture. This time, let's say that we have the circle on the outside, and inside of it we have a square. So what I'm going to do is, let's see, we have to have a little bit more information here. So we're going to say that the radius is, I don't know, let's say that the radius is 10. And then let's say that the side of a square, let's just say that the square, just the measure of one side of it, will be 3.2. All right, and this time they want you to find the probability of the shaded region. So let's do this. That's our shaded region. And again, we're just going to follow the same format that I was just talking about. So we're going to do that, the probability of success over probability total. Again, we're assuming that if we're throwing a dart at this, it has to fall within that circular range. So the shaded area is our success. The shaded area is the shape of that is a square. So we're going to need to find the area of the square. And on the bottom, the total region, that square sits inside of that circle completely. So as long as we find the area of the circle, we're in good shape. Okay, so now let's plug in formulas. The area of the square is s squared. Pi r squared is the formula for our area of a circle. Now we just plug in the numbers. 3.2 squared on the top. Pi is 3.14 on the bottom. Our radius is 10. And now we're ready to just grab a calculator. And let's see, 3.2 squared comes out to be 10.24 on the bottom. Pi times 10 squared, that's 314. And then we also want to divide that out. So 10.24 divided by 314 gives us 0.033, which is a very low probability. So I'm thinking that my picture is not drawn to scale at all, because that's really, really tiny. Could be that I made a mistake when I copied the problem down too. That could always be it. So let's try one more. This one's just a smidge more complex. But again, I'm going to follow the same exact steps that I already had. So this time we're going to go back to having a square on the outside. We're going to say that one side of it is 16. And we know that all four of these are equal. And then inside of it we have a circle. Pretend that comes over here and meets that. And there we go. And then this time, let's say that our shaded region is here, because that would be tricky to do. All right. Again, we're going to just follow the same steps. We're not going to vary our process. So we want to do success over total. Success is the shaded. So for the shaded region, it's not the circle anymore. To find the shaded region only, we're going to have to find the area of the square and then subtract out the circle. And that would leave us all of these little areas up here. All right. That's going to be a little bit more complicated, a little ugly looking on the top, but that's totally okay. So it's going to be the area of the square minus the area of the circle. Again, don't let it freak you out. We know the formula for square. We know the formula for a circle. Like it just looks a little messier, but other than that, we're doing exactly the same thing. The total area is still the entire square. All right, and so we're just going to plug that in. Don't try to do any fancy canceling, especially since it's illegal. Like you can't cancel these two areas out because you have to do that subtraction on the top first before you can cancel or reduce anything out. So don't be tempted. That would be illegal math. So let's put in the formulas. The area of the square is s squared, and we're going to minus out pi r squared, and that's going to be all over s squared. Again, we cannot cancel those s squareds, not allowed. Now let's put in some numbers. The measure of the side of the square is 16, and then pi is 3.14. Well, what is the radius? Well, if this whole thing is 16, our radius is going to be half of that, so that's going to be 8. So from here to here is 8. All the way across would be 16. On the bottom of this fraction, we need s squared again, which is 16 squared. Now we're ready to just take our calculators out, and let's see, 16 times 16 is 256, and then pi times 8 squared, that's 200.96. We have our 256 again on the bottom. So if we do 256 minus 200.96, we get 55.04. And now whoops, kind of messy, but that's how I am in real life too. So 55.04, whenever you see that fraction bar, I didn't say that earlier, but it does mean to divide. And then when we do divide that out, it comes out to be 0.215, or roughly, if you wanted a percent, 22%. And again, when you look at the picture, this one makes a lot more sense than the last one. That shaded region only takes up a little bit of that square. So we're not expecting it to be up to around 100%. It's less than a quarter, and that makes complete sense. All right, well, you've seen a couple of these. I hope it helps a little bit. Again, try to parse out, like, what is success? It's usually the shaded region. what do you need for the shaded region, what shape is it, or what combination of shapes. The bottom of the fraction is always the total, or usually it's like the biggest part, the biggest item of the initial problem that you're given. And then just plug them in. Go from words to kind of like what it represents in your picture, to formulas, to numbers. Just take it step by step. All right, thank you.